and we're going to talk about the different parts of the real number system. We have integers, which are positive and negative whole numbers. There'll be another presentation on that particular aspect. We also have rational numbers. That's any number that can be expressed as a fraction. There will be a different video for that one as well. Irrational numbers are numbers that are not rational. They are non-terminating, non-repeating decimals, and your most common examples are square roots of numbers that are not perfect squares, such as the square root of 2. If you would put it in the calculator, if you calculated enough spaces on it, it would go on forever. Never repeats, never terminates, and that's why it's an irrational number. Particularly on this particular presentation, we're going to talk about every time someone sees this symbol, they always say that's a square root sign, which is incorrect. That's a radical symbol, because if there's no number in front of it, it is a square root, which means it's what number can you multiply by itself and get the number inside. But if there's another number here, a 3 or 4 or 5 or 6 or whatever, then that gives you a completely different problem. So without a number in front of it, it is a square root of 64. So you want to know what number can you multiply by itself and get 64, and the answer would be 8. When you put a number in front of that radical sign, it tells you how many times you have to multiply the number to get the answer to the number inside of the radical sign. This is the cube root, so you have to think of a number that you multiply by itself 3 times, you get 125, which would be 5 times 5 times 5. A lot of people confuse that. Every time they see the symbol, they just say square root. Not true, unless it has no number in front of the radical sign. So some fractional exponents. 3 squared, it means you take the 3 and use it 2 times. 3 times 3 is 9. 5 to the first power means you only use the 5 one time. 4 to the 0 power means you don't use the 4 at all. Anything to the 0 power except 0 is always 1. And this is 8 to the 1/3 power, which is the same thing as the cube root of 8. So these two notations are interchangeable. Some people don't understand when they see 8 to the 1/3, they don't understand that's the same thing as the cube root of 8. So what you're trying to find is, what number can I multiply by itself 3 times and get 8? And of course that would be 2 times 2 times 2. So 8 to the 1/3 is 2, which is the same thing as the cube root of 8, which is 2. So we have some laws that we have to follow when we do exponents. The first one is, when you have the same base and you're multiplying, all you do is add the exponents together. The second one is, if you're dividing and they have the same base, all you do is subtract the exponents. The next one is, if you have a negative exponent, all you do is basically put a 1 on the top of it and take this entire thing and just slide it to the bottom, which makes the exponent positive. The fourth one is a fractional one, which is what we just did. When I had the 8 to the 1/3, I told you that was a cube root of 8. So anytime you see a fractional exponent, this number goes on the inside and the bottom number goes on the outside. So the good news is, most of the ones you're going to see, they're going to let you use a calculator to figure out the answer. The buttons that I'm going to show you, I'll go back and forth from this slide to the next one when I show you how to do these particular problems. We have an enlarged view so you can see it more clearly. So when I did that 8 to the 1/3 earlier, I told you that was the same thing as a cube root of 8. If you want to use a calculator, all you do is hit the 3, then you hit the square root symbol, which is green in this particular calculator to get, it's the cube root. So I do 3. I want to do this button here because right above it says x square root. So that's where the 3 fits into. And then if I hit the 8 and hit enter, it'll tell me the answer is 2. There's some more demonstrations on that one. I'll show you which buttons to hit on those particular ones. So we've got some, next slide has some examples on it. We've got some different kinds of problems, so I'll give you an example of each of the 4 different kinds. That way you'll be more comfortable with it. This is the cube root of 216. If I were to push the buttons on the calculator, I would hit the 3. I would hit that second button, which takes me to the symbols above each one of the buttons on the calculator. I hit the upside down V button, which gives me that square root with that little X in it. So I'm doing the 3rd root, and then I hit the 2, the 1, and the 6, and I hit enter. It'll give me an answer of 6. Also, you can find these specific directions like you have the Texas Instrument booklet that goes with your calculators. It's on page 16 and 17 in that Texas Instrument book. So again, if I'm doing this cube root of 216, I'm going to hit the 3, I'm going to hit the second button, I'm going to hit this upside down V button, I'm going to go 2, 1, 6, enter, and it's going to give me the answer. The next problem is 9 to the 3rd power plus 4 to the 0 power plus 16 to the 1/4. On the calculator, it will look like this. If I do 9 to the 3rd power on the calculator, all I do is hit the 9 button, I hit the upside down V button, I hit 3, and I hit enter, and it'll give the answer of 729. So again, if I'm doing 9 to the 3rd, all I do is hit 9, upside down V, that raises me to whatever power I'm looking for. I hit the 3, and I hit enter, and it'll tell me that's 729, which is 9 times 9 times 9. So I have this part. Now if I do the 4 to the 0 on the calculator to get that answer, I hit the 4, I again hit the upside down V button, I hit 0, I hit enter, it'll tell me that is 1. So 4 to the 0 power is hit the 4, hit the upside down V, hit the 0, hit enter, it'll tell you that equals 1. And then the next part of it is 16 to the 1/4. To the 1/4 is the same thing as the 4th root of 16. To do that on the calculator, I'm going to hit the 4, I'm going to hit the second button, I'm going to hit that upside down V, I'm going to hit the 1 and the 6, I'm going to hit enter, and that's going to tell me that is 2. To the 1/4 is the same thing as the 4th root of 16. So when I go back and put it all together, we had this was 729 plus 1 plus 2, 732. When you had your negative exponent earlier, I told you law of exponents said that all you do is take this whole thing, put it on the bottom, and put a 1 on the top of it. So to get that answer, if you push the calculator, all you have to do is hit the 1, the 2, the upside down arrow. I'm going to hit the negative sign button. I'm going to hit the 2. And I'm going to hit enter. It'll tell me it's 1 over 144. Here's what that one looks like. I'm going to show you how to do the 12 to the negative 2 power on the calculator. Hit the 1, hit the 2, that's your 12. Upside down B. Here's the negative sign. And 2, and enter. And it should read out when you get finished 1 over 144. And then the last problem in that set of examples is 3 to the 3rd power times 3 to the 2nd power. If you remember that law of exponents, when we have the same base, we keep the base the same and all we do is add the exponents. So this is 3 to the 5th power, which means I use the 3 5 times. To do that on the calculator, 3 to the 5th power. I hit the 3, upside down B to the 5th power, and hit enter. So that's 3 to the 5th power, 43, because I didn't remember off the top of my head. So we got 3 to the 5th power is 243. That's going to be your 3 button, upside down B, 5, enter. So that's how you can do it on the calculator. So now I have a real world application. We got a square park, side length 3 miles, diagonal square is 18. Jeff will walk diagonally across the park 50 minutes. How long will it take Jeff to walk around the perimeter of the park? The key here is it's a square. This is the diagonal. And we want to know about the perimeter. So those are the terms you need to know to do this problem. So we have a square. Said each side is 3. It tells us that he's going to walk the diagonal, which is the square root of 18. So basically what you remember on this problem is the Pythagorean theorem, where you have a squared plus b squared equals c squared. So if you look at just one part of the square, you would have this right triangle. You'd have 3 here, and that hypotenuse is square root of 18. And you can prove that is true by putting the 3 in for A and this 3 in for B, square root of 18 here. 3 squared is 9. 3 squared again is 9. Square root of 18 squared is 18, so that is true. So the question becomes, if he can walk from this distance in 50 minutes, that only takes care of half of the square, and the perimeter means he wants to start at one location and walk all the way around to back where he starts from. So if square root of 18, if that takes him 50 minutes, that's basically half of what he has to walk from here to here. So he has to walk the other distance from here to here, which means you take 50 minutes and add another 50 minutes to include the whole square, which is 100 minutes. And 100 minutes is the same thing as 1 The next example is, I have a cube-shaped box with a volume of 750 cubic centimeters, which expression shows the area in centimeters squared of one face of the cube. Lots of vocabulary here. I got a cube, we're talking about volume, then we want to know area of one of the faces. So if you look at a cube, cube has top, bottom, 4 sides, total of 6 faces. Each one of them will have the exact same area. So if the volume is 750, to get the volume, you multiply the length times the width times the height. So if you have the area would be the length times the width. So that takes up 2 parts out of 3. So if you're looking for one of the faces, you want to take that 750, and basically instead of having 3 parts, you only got 2, that's 2/3. And if you got 6 faces, you divide it by 6, and that would be answer D. And then have test taking tips for you. Use the answer choices to solve the problems. Here's your example. You have square root of 40 times the cube root of 8 divided by square root of 2. You want to know which one of these is equivalent to that particular expression. This is square root, so it can't be that one, that's cube root. If you looked at the square root of 40, that's the same thing as the square root of 4 times 10, which is the same thing as the square root of 4 times the square root of 10. And I know the square root of 4 is 2. So basically, in place of the square root of 40, I'm going to put 2 times the square root of 10 in there. If I wanted to find that, that would be 2, but that's not one of my choices. And if I leave the square root of 2 there the same, I could find that this is the correct answer. It would be A. All they did was change the square root of 40 into 2 times the square root of 10. They left the cube root of 8 the same. They left the square root of 2 the same. And that will conclude our demonstration on radical expressions and roots.